Hello viewers, so welcome to my channel. I'm Hasham. So far I have completed 4 problems on Poisson distribution in the last video. In this video, next 5th, 6th, 7th, these 3 problems I am going to explain in this video. So binomial distribution is the limiting factor of, Poisson distribution is the limiting factor of binomial distribution. When n is very large and p is very small, it is better to apply Poisson distribution rather than binomial distribution. Actually, the purpose is same. The probability of our successes we have to find out by binomial as well as Poisson. But binomial distribution is suitable when only n is small. If n is very large, then Poisson distribution. All these things I have already explained in the theory video of Poisson distribution. So before watching the problems, I suggest you be acquainted, be clear regarding this formula, regarding the concept of Poisson distribution. So if you have not watched the earlier video, go to the playlist of my channel. Select the subject statistics for management. Select the video of Poisson distribution theory. Be perfect on the concept, then you come to the problem. Now before starting the 5th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points of these 3 problems, then I'll explain every point in detail. Now, see the problem number 5. 5th problem. Assume that the probability of a fatal accident in a factory during the year is 1 by 1200. So 1 by 1200 is the probability of fatal accident in a factory. Calculate the probability that in a factory employing 300 workers, the number of workers are 300, there will be at least 2 fatal accidents in a year. What is the probability? What is the chance that in a particular year, at least 2, minimum 2 fatal accident taking place in the factory? First of all, it is not given whether Poisson or binomial. By seeing the contents of the problem, we have to decide ourselves. The value of n is large because 200 workers are there. N is 200. N is very big. P is very small because 1 divided by 1200. This is the probability of fatal accident. So since P is very small and N is very large, so we can apply Poisson distribution in this problem. So here P is equal to probability of fatal accident 1 by 1200. N is equal to number of workers in the factory 300. M is equal to N into P. There is only single parameter in Poisson distribution, M. And how to find out M? N into P. The number of workers are 300 into probability 1 by 1200. So it comes to 0.25. So M is equal to 0.25. E to the power of minus M. E to the power of minus 0.25. Now you have to refer the table. The M value is in fraction. So that's why the upper big table, this table you have to refer, right? For fractional values. If the M value is in a whole number, then below small table is there. That small table we have to refer for whole numbers. And for fraction, first table. Now, 0.25. The 0.2 under 5. So in this 0.2 row under 5, you will find 0.7788. So against 0.2 under 5, because 0.25. 0.25. So 0.2 row and 5 column. You will find 0.7788. I'll provide this table in the link under my description. So you can take a printout of this table value. Or else in every textbook you will find e to the power of minus m. Poisson distribution table value. So 0.7788. So according to Poisson probability law, probability of R successes already we have applied in the previous problems. P of R is equal to e to the power of minus m into m to the power of R divided by R factorial. Now, probability of at least 2 fatal accidents in a year. At least means minimum. In a year, minimum 2. That means 2, 3, 4, 5, 6, any number. But minimum is 2. So, R is greater than or equal to 2. 2 or more than 2. So, the probability will be 2, P of 2 plus P of 3 plus P of 4 plus P of 5 plus P of 6 plus P of 7. Like that it goes on. That means up to infinity. So, we can't calculate up to infinity P of 2, P of 3, P of 4, P of 5. The alternative method is there. There is an alternative formula. The alternative formula is before 2. Before 2, the probabilities are 0 and 1. These two probabilities we deduct from 1. So alternatively, P of R greater than equal to 2 is equal to 1 minus P of 0 plus P of 1. So here we are starting from 2. So before 2, the probabilities are 0 and 1. So these two probabilities we add up and the total will be deducted from 1. So 1 minus P of 0 plus P of 1. Now first of all, P of 0. P of 0 e to the power of minus 0.25 into 0.25 to the power of R. What is the R value? 0. And 0 factorial. E to the power of 0.25. Already we have calculated 0.7788. 0.25 to the power of 0. Anything raised to the power of 0 will be 1. Already I told you mathematically. So divide by 0 factorial. 0 factorial always equals to 1. When you watch the video, I suggest you to keep a notebook, calculator, pen beside you. Whenever I say something which you don't know, immediately you should write it down. Then only you can be able to remember. Don't simply watch and listen the video. Now, so P of 0 is 0.7788. Now we have to find out P of 1. So e to the power of minus 0.25, 0.25 to the power of 1 divided by 1 factorial. So in place of R, I am substituting 1. Wherever R is there, I am substituting 1. So now e to the power of minus 0.25, you will get 0.7788. Already we have calculated here. We have taken from the table value. Into 0.25 to the power of 1 is 0.25. 1 factorial is also equal to 1. 0 factorial is 1. 1 factorial is also 1. Now finally P of 1 is equal to 0.1947. So we got P of 0 and we got P of 1. Now P of R greater than equal to 2 is equal to 1 minus P of 0 plus P of 1. P of 0 is 0.7788 and P of 1 is 0.1947. Add up these two values, you will get 0.9735. So 1 minus 0.9735, 0.0265. That's all. 0.0265. This is the probability of at least 2 fatal accidents in the factory during a year. Minimum 2 fatal accidents. 2 or more fatal accidents. The probability is 0.0265. That's all. Now, sixth problem. Problem number 6. If 2% of electric bulbs manufactured in a certain factory, certain company are defective, the probability of defective bulb is 2%. That means for every 100 bulbs produced, 2 bulbs may be defective. Now, find the probability that in a sample of 200 bulbs, so n is equal to 200. Less than 2 bulbs and more than 3 bulbs are defective. So, 2 different questions are there. What is the probability that less than 2 bulbs are defective? What is the probability that more than 3 bulbs are defective? That's all. So, first of all, we'll denote P is equal to probability of defective bulb 2%. 2% means 2 by 100, 0.02. N is equal to number of bulbs. Number of bulbs we have taken 200. So, M is equal to NP. So, 200 into 0.02, 4. So, M is equal to 4. E to the power of minus M is equal to E to the power of minus 4. Here M is whole number. When N is in whole number, see the below table, small table is there. In that small table you can see E to the power of minus 4 is 0.01832. 0.01832. That is the value of e to the power of minus 4. So 0.01832. Since p is very small and n is large, so we apply Poisson probability law, according to which p of r is equal to e to the power of minus m into m to the power of r by r factorial. That is, p of r is equal to e to the power of minus 4 into 4 to the power of r divided by r factorial. Right? Now one by one question. First question, probability that less than 2 bulbs are defective. Less than 2. That means r is less than 2. Less than 2 means the probability of 0 and 1. Below 2 it is saying not 2 or less than 2. If it is less than or equal to 2, that means we should take 2 also. But here it is saying less than 2, means we should take only 0 and 1. These two values are less than 2. So p of r less than 2 is equal to p of 0 plus p of 1. P of 0, e to the power of minus 4 into 4 to the power of 0 by 0 factorial. E to the power of minus 4 already we calculated, here we got 0.01832 into 4 to the power of 0 is 1. 0 factorial is 1. So p of 0, 0.01832. So one value we got, p of 0. Now p of 1, e to the power of minus 4, 4 to the power of 1 by 1 factorial. 1 factorial means 1. 4 to the power of 1 means 4. Now multiply p of 1, we got 0.07328. So we got p of 0 and we got p of 1. So p of r less than 2 is equal to, add up both the values, we'll get 0.0916. This is the probability that less than 2 bulbs are defective. 0.0916. So probability that less than 2 bulbs are defective is 0.0916. That's all. Now second question in this one is probability that more than 3 bulbs are defective. More than 3. That means we have to take from 4. Greater than 3 means we have to take from 4. 4, 5, 6, 7, 8 like that. So probability that more than 3 bulbs are defective, r is greater than 3. When we say greater than 3, we have to start from 4. So 4, 5, 6, 7, 8, 9 like that we have to go up to how many bulbs? 200 bulbs. So can we calculate up to 200 probabilities? It is highly difficult. So alternative formula. Alternatively, p of r greater than 3 is equal to 1 minus. Now before 4, p of 4. Before p of 4, what are the probabilities? P of 0, P of 1, P of 2, P of 3. These are the probabilities before 4. So 1 minus P of 0 plus P of 1 plus P of 2 plus P of 3. These 4 probabilities we calculate and add up. Then we deduct 1 minus this, we'll get P of r is greater than 3. Right? So out of these 4 probabilities, P of 0 and P of 1 already we have calculated here. P of 0 we have calculated, P of 1 also we have calculated. The only thing we need P of 2 and P of 3. So P of 2 is equal to e to the power of minus 4, 4 to the power of 2 divided by 2 factorial. 2 factorial means 2 into 1. 2 into 1 is 2. 4 square, 4 4s is 16. Then P of 2 we got 0.14656. So we got P of 2. Now lastly we need P of 3. So here P of 3 is equal to e to the power of minus 4 into 4 to the power of 3 divided by 3 factorial. 3 factorial means 3 into 2 into 1, 6. And 4 cube, 4 into 4 into 4. 4 4s are 16, 16 4s are 64. Now finally P of 3 is equal to 0.19541. So we got P of 2 and P of 3. Finally we got all P of 0, P of 1, P of 2, P of 3. Here P of r greater than 3 is equal to 1 minus P of 0 plus P of 1 plus P of 2 plus P of 3. Because it is saying more than 3, that means it will start from 4. So instead of calculating from 4, we have calculated up to 3. Now we take the values. P of 0. P of 0 is 0.01832. Then P of 1 is 0.07328. Then P of 2 is 0.14656 and P of 3 is 0.19541. Add up all these four values, we'll get 0.43357. So 1 minus 0.43357, you get 0.56643. This is the probability that R is greater than 3. Probability that more than 3 bulbs are defective is 0.56643. That's all. So this is the end of 6th problem. Now 7th problem. 7th problem says a book contains 100 misprints distributed randomly throughout its 100 pages. The book contains totally 100 pages, and in those 100 pages we find 100 misprints are there. So what is the probability that a page observed at random contains at least 2 misprints? Assume Poisson distribution. Specifically given in the problem that we have to apply Poisson distribution, right? For Poisson distribution, the main parameter is M. M means average. In the previous problem, to find out M, we multiply N into P. But in this problem, M is directly given. M stands for average misprint per page. Average misprint per page. The 100 misprints are there in 100 pages. On 100 pages, 100 misprints. So per page, 1 misprint on an average. On an average, 1 page, 1 misprint. So here we can say M is equal to average misprint per page. So M is equal to 100 by 100 is equal to 1. So we can say on an average, we have 1 misprint per page. So 100 pages, 100 misprints. So M is equal to 1. E to the power of minus M is e to the power of minus 1. So e to the power of minus 1, again it's a whole number. So small table. Here in the small table, e to the power of minus M, you can see 0.36788. 0.36788. This is the value of e to the power of minus 1. Now according to Poisson, e to the power P of R is equal to e to the power of minus M into M to the power of R by R factorial. So here P of R e to the power of minus 1 into 1 to the power of R by R factorial. This is the formula we are going to use. Now ultimately, what is the question? What is the probability that at least 2 misprints are there on a page? What is the probability of at least 2 misprints? Probability that a page contains at least 2 misprints. That is, at least means minimum. At least means minimum. Minimum 2 it is saying. So 2, 3, 4, 5, 6, any number of misprints may occur. So R is greater than equal to 2. So we can say P of R greater than or equal to 2. P of 2, P of 3, P of 4, P of 5, P of 6, any number. In unlimited misprints may be there. So it is difficult to calculate like this. 2, 3, 4, all the probabilities we have to calculate. It is time consuming. So we apply alternative method. So before 2, the probabilities are P of 0 and P of 1. So alternatively we calculate 1 minus P of 0 plus P of 1. Here 1 minus P of 0 plus P of 1. So we need P of 0, e to the power of minus 1, 1 to the power of 0 by 0 factorial. 1 to the power of 0 is 1, 0 factorial is 1. So P of 0 is 0.36788. We got P of 0. Now P of 1, e to the power of minus 1 into 1 to the power of 1 divided by 1 factorial. 1 factorial means 1, 1 to the power of 1 means 1. So again we got the same P of 1 is equal to 0.36788. Finally we substitute P of R greater than equal to 2 is equal to 1 minus P of 0 plus P of 1. Now add up the two values, we'll get 0.73576. So 1 minus 0.73576 will get 0.26424. 0.26424. Therefore, probability that at least 2 misprints on a page, at least 2, minimum 2 misprints on a page is 0.26424. That's all. So in this video, I have explained you in detail every point I have explained, 5th, 6th and 7th. So if you want the perfect knowledge, watch the video not once, twice, thrice. Then only you can get the perfection. In the first instance itself, you may not be able to understand, right? So if you are satisfied, give a like to the video, share my channel among your groups, among your friend circles, so that more students can watch the video and enhance the knowledge. Give your comments on these videos. And lastly, don't forget to subscribe. My viewers are increasing, but subscribers are very low. The students are not subscribing. Please subscribe my channel. It gives me more motivation. And lastly, buy the super thanks which is given below my video.